Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on inverse functions and their graphs. In the last lesson, we learned about the inversion of functions and about identity on functions. Today, we will learn to sketch the graph of the inverse of a function. We will also review the concepts that we have learned in this unit. If you are ready, we will begin. Students, do you remember how to obtain the graph of the inverse of a relation? We find it by reflecting the graph of the relation of the line y equals x. Let us practice this with an activity. Sketch the graphs of these two functions. Then sketch the graphs of their inverses.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to graph each of the functions? How about their inverses? These are the points that are plotted by function A. Here is the graph that is produced. Now we must calculate the inverse of the function. As you may remember from our last lesson, we find the inverse by transposing x and y. Then we solve the equation for y. In this case, x equals y minus 5 over 3. Therefore, 3x equals y minus 5, which can be expressed as y equals 3x plus 5. The table of values for the function 3x plus 5 gives us this series of points. Therefore, the graph of the inverse function of a looks like this. Now we must repeat the same procedure for function b. First, we see that function b gives us this series of points. Therefore, the graph of function b is plotted in this way. Now we find the inverse of function b. X plus 1 equals y cubed. Therefore, y equals the cube root of x plus 1. The table of values for the function cube root of x plus 1 gives us this series of points. So the graph of the inverse function of b looks like this. If these results resemble yours, great job. We can also sketch the graph of a function's inverse by looking at the graph of the function. For example, here is the graph of the function f of x equals x to the power of 5. To help us find the inverse graph, let us draw a dotted line representing the basic function f of x equals x. We can use this line as a guide to find the inverse of the function. Here is the graph of the function's inverse. It appears as if the function is being reflected from f of x equals x to produce its inverse. Remember that the domain of a function is the range of its inverse, and the range of a function is the domain of its inverse. Try this for yourselves, students. For each of the following graphs, sketch the inverse of the function.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. This was a very simple exercise, was it not? Here is function A. As you can see, first we draw a line representing f of x equals x. It then becomes much easier to graph function A's inverse, which looks like this. We can find the inverse of function B in the same way. First, f of x equals x is drawn, then the inverse. Function C might have been a bit more tricky. Because of the nature of the function, the graph is already symmetrical along f of x equals x. This means that the graph of the function is identical to the graph of the inverse. If you figured this out on your own, well done. You are showing a good grasp of the concept of inversion. Now, let us review what we have learned in this unit. I will present you with a series of statements with missing words. Working with a partner, please fill in the blanks. Each set of questions will only appear for a few moments, so you will have to be quick. Are you ready, students? You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I am sure you had no trouble filling in the blanks. Let us review your answers together. A relation from A to B is any subset of A cross B. The domain of the inverse of R is the range of R. Similarly, the range of the inverse of R is the domain of R. A relation in which no two of the ordered pairs have the same first element is called a function. This is called an absolute function. You are also correct if you called it a modulus function. This is called a Signum function. This is called a greatest integer or floor function. If f of x1 equals f of x2, then x1 equals x2 for any x1 and x2 that are in the domain of f. F is 1 to 1. If the range of f equals b, then f is onto. If f is both 1 to 1 and onto, then it is a 1 to 1 correspondence. Were all of your answers correct, students? Great job. In this unit, we have expanded our knowledge of relations. We reminded ourselves how to sketch the graph of a relation and its inverse. We learned about modulus, signum, and floor functions. We also studied one-to-one and onto functions, as well as one-to-one correspondences. Finally, we have learned to find the inverse of a function and sketch the result. You have all done very well in this unit. I will be expecting you to work just as hard as we move forward. That is all for today. Until next lesson, thank you, teacher. Thank you, students.